Hi everybody, my name is James and I'm going to be doing question 18 from chapter 4. So the question says, a man pulling an empty wagon causes it to accelerate at 1.4 meters per second squared. What will the acceleration be if he pulls with the same force when the wagon contains a child whose mass is 3 times that of the wagon? So we first want to use Newton's second law of motion, and that says force equals mass times acceleration. So the question gives us a mass and an acceleration, but it doesn't give us the number for the mass, but it tells us that the force the man is pulling with is the mass of the wagon times 1.4 meters per second squared. So we know the force that the man pulls with when the wagon is empty. And he's pulling with the same force when he pulls the child, so then we can add that into an equation when we calculate the other acceleration. We also need to know the mass for when he's pulling the child in the wagon. So to get the mass of the wagon plus the child, we have the mass of the wagon plus the child is 3 times the mass of the wagon, so 3 times the mass of the wagon. So the mass of the wagon plus the child is 4 times the mass of the wagon. And so then if we set up the second law of motion again, force equals mass times acceleration, we can find the acceleration when the man pulls the wagon with the child. So the force is this one right here. So it's the mass of the wagon times 1.4 meters per second squared equals this mass. So 4 times the mass of the wagon times the acceleration. So to get the acceleration, we have to move these numbers to the other side of the equation. So we have 4 divided by the mass of the wagon to both sides. Since the mass of the wagon is in the numerator and the denominator, we can cancel it out. And so we get 1.4 meters per second squared over 4 with no units equals acceleration. And because the 4 has no units, our answers will still be meters per second squared. And that answer is 0.35 meters per second squared is the acceleration when the man pulls